All right, good morning, folks. Good to see you on a Monday. Good to have everyone in here. All right, so today we are going to talk about some shielded metal arc welding electrodes because we're moving into arc 1 and 2. So what I have today is a electrodes PowerPoint. And what we're going to do is we're going to talk about that a bit. 29 slides. Not all of them apply to what we're doing, but we're going to glance over them. And tomorrow I'm going to have a worksheet and an answer sheet. It's got the information on it. You basically have to pull the information out of the worksheet. And then we'll do a couple more things related to electrodes over the next rest of this week. And probably move into a bit of transformers and maybe some health and safety as well. So we got lots to cover in the next bit, but I'm only giving you guys what I need to. I'm not creating any fluff for you. You know, I'm not about that. So what I'm going to do is I'm going to share my screen. I'm going to pop open this presentation. See if I can find it. It should be here. And the resources and content. You guys should be able to see this as well. I've opened it up for everyone. So it should be under class material, Electrode PowerPoint. And we'll pop this open here. Let's bring this up, see if I can figure out how to present this one. It's a pages document, and that's not what I wanted. Well, that's not exactly what I wanted. That's not good. Okay, well, what we're gonna do is we're just gonna work through it anyways, because it's easy enough to work with. Let's see, this is fit page. Let's do that one. Let's go this way. We'll go this way. And we'll hide this. Okay. All right, welding electrodes. When, where, and why? Well, there's a whole bunch of different types and a whole bunch of different reasons as to why we would use certain rods. So some of it is simply for economy. They are cheap, they do the job. They're on sale, they suffice. You know, it's lots of reasons, but other times we're stuck and bound to certain specific electrodes. And that could be because that's what the job calls for. That's what the engineer calls for. And then we have to follow whatever they are asking of us. So it's our job to know and be informed and be able to make choices, but also to follow direction when instructed to. So electrodes, what the heck are electrodes? You know, a lot of different terms for them, rods, sticks, stuff like that. We use them all in here, but electrode is a proper term. So in arc welding, an electrode is used to conduct electricity through a workpiece to fuse two pieces together. Depending on the process, like in gas metal arc welding or shielded metal arc welding, the electrode is consumable. That means we use up the electrode. Whereas gas tungsten arc welding or TIG welding, the electrode is non-consumable. So in gas tungsten arc welding, the electrode is tungsten. It conducts electricity. That electricity, we use that to melt the base metal, and then we add our filler metal in. So think of it as an electric torch kind of thing. So if you're brazing or electric brazing, that might be a good way of talking about that too. Consumable electrodes are going to be shielded metal arc welding rods that we've seen, and gas metal arc welding electrodes, wire of all sorts. Could be solid wire, could be flux core, could be metal core. Just wire format. Anything that is where the rod or electrode becomes the puddle, that's considered a consumable electrode. And then we have non-consumable. We got tungsten for the TIG process. Those should not end up in your weld puddle, although if you are learning, there is a chance that the tip of your tungsten will end up in a weld puddle at some point. If that weld needs to be inspected, we need to get that tungsten out of there. You got to grind that out, get it gone, because we don't want those inclusions. So with tungsten, if you end up sticking that tip in there, you break the tip off in the puddle, and that gets x-rayed, it's gonna glow bright white like a star in the middle of your weld, just because the density of tungsten is so heavy. That is definitely not something we want. So we don't want to touch or contact the tip of that electrode to our puddle at all. So welding rods developed in 1888 by Nikolai Slavinov. I think I got that right. First coated electrode was developed in 1900. So welding's been around for a while, 1888. Oh geez, almost 150 years. It's pretty crazy. First coated electrode was developed in 1900, which is cool. Used in the shielded metal arc welding process. Comes in a variety of types and sizes. Just from your guys' knowledge, what are the basic electrodes that we use in the shop here? Nothing, not even in the chat. All right, so basic electrodes we use in the shop are 7018. So that's our low hydrogen welding rod. We have 7014, which is a bit of a learning rod. We have 6010, which is a high deposition fast freeze rod. That's what we use to put the roots in on pipe. So there's a couple of the rods we use. So the anatomy of a welding rod. A welding rod has 4 components that are important to know. Firstly, the core wire. That's steel rod running all the way down from the tip to tip. The flux coating, that is the coating on the outside that helps protect the rod, gives it properties, helps have cleaning agents, and slows down the cooling of our weld. We also have the exposed core wire. That's where we're going to contact that to our clamp. So if we're, putting a rod in a stinger, that's the exposed core wire is going to go in the stinger. That's how it makes that electrical contact. And the tip is the end, obviously, that we're going to touch down to our steel, start working with. So what we have here is a breakdown of that anatomy. So if you guys saw, maybe you didn't, I did bring in a different type of electrode holder as a clamp style. It's going to be very similar to the one on the top of this picture here. So we see the exposed core wire gets popped into the clamp, got the electrode holder, covered electrode and the arc at the end, then a bit of an animation at the bottom as to the welding process broken down. So core wire of electrode is the metal that runs through the length of the rod. Neat thing about these welding rods is they actually aren't made of very high quality steel. They're made of decent steel, but since we have the cleaning agents in the flux, we can actually get away with using steel that isn't 100% purified, because the cleaning agents in the flux will help float impurities to the surface and get rid of them, helping clean the steel as we weld it. Basically, the core wire conducts the current from the plate to the stinger. It is consumable, it melts. We all know this. It creates our weld deposit, and the exposed end is inserted into the electrode holder. Okay, we've got that. A little breakdown on the picture here. So we got our flux coating, we got a core wire. It's called a crucible cup. Is normally what happens is the flux sticks a little farther out past the end of the rod, and the flux burns back towards the core wire. What that does, it does a couple things. With it burning this way, it helps kind of direct and project the steel out the end of the rod. You guys notice when you fire up a brand new rod, sometimes the arc is very unstable at the beginning. You'll fire up a rod, it'll wobble, it'll kind of dance around a bit, then it'll settle in. Basically what's happening is that core wire burns back about 1/8 of an inch into the crucible cup. During that time where it's burning back at 1/8 of an inch, that's when that arc is unstable. And then once it's got that cup, the cup starts directing the steel to where you want it to go. That's when it stabilizes and becomes very controllable. Uses a globular process, so it throws globs of steel across the arc. We have our base metal here being penetrated into. turned up with our weld metal, and then we got our slag covering over top. And also with the flux burning off, we have a gas shield that is being created by some shielding agents. So I talked about the crucible cup right here. This is exactly what that is. So we have this flux on the outside, burning slower than the core wire on the inside. And then what that does is kind of directs that electrical arc. So that is what helps us have a nice, stable, predictable bead as long as we keep our arc length appropriate. If you open up that arc length to 1/2 inch, that arc's going to dance around regardless. So I keep my arc length 1/8 or under. I work with a very short arc. Flux coating is covering on the core wire, stabilizes and directs the arc, prevents contact of the core wire with metal components. Yeah, because if we lay this on our table in our stinger, usually we're fine, but if we're missing a bunch of flux here, it's going to ground out, stick that table. I don't know if you guys have ever done that in one of the booths accidentally, whatever, it doesn't really matter. But you stick a rod or it sticks, and what's going to happen is it's going to start heating up red. It's going to burn off all the flux, and usually the rod basically disintegrates. Because what we've created there is a dead short. So we're just running 100% power through that rod. Resistance in that rod generates heat. So as we see heat build because of the resistance of the steel, that's when we get that color transformation. That's when it starts to glow and it'll sparkle and basically just burn to a point where the steel separates, the contact is no longer made. And yeah, then that dead short has been stopped. But I've done it a few times in class. I've probably shown you guys once. If not, I'll show you when you get back. Yeah, stabilizes, directs the arc, prevents contact. Found on all shielded metal arc welding electrodes. Some have a thicker coating than others. Some have a thinner coating. 7018, Zgotta coating is probably, I don't know, a couple mil. It's a good size thickness, but then you look at something like a 70 or a 6010, it's got a very thin coating on the outside of it. So different components in that flux will do different things. And in 7018, we're seeing a lot of stuff like lime, whereas 6010, we're going to see a lot of cellulose. That's why it kind of smells like burning paper or burning wood. Composition determines the properties of the rod. So yeah, contact area and tip. The exposed core wire and end of the electrode gets inserted into the electrode holder. Allows the flow of electrons to pass through the electrode and the electrical circuit to be closed when an arc is struck. So basically, yeah, we're just closing the loop when we strike the arc. The other end of the rod is where, yeah, well, we know that. So what do you need to know about electrodes? The first thing you need to know about electrodes is they're not all the same. They all do different things. The steel may be the same for all of them, but the properties they have and the way they're run is going to be different. So they come in different sizes, compositions, and made for different purposes. Selecting the wrong electrode for the job can make the job much more difficult, and welds could possibly fail if the job says use this certain type of rod and you don't have any and you just decide to use a different rod. Well, if that rod is not approved or is not an equivalent to the one that you're asked to use, you may be grinding all that out, redoing it. So if you ever have to substitute a rod, and it's very important that you are using a certain type of rod, you always have to clear with a boss or an engineer, or just simply go get more of the rod you need. Because even if it takes you an hour to go get some of that rod, it's going to take you 6, 8, 10 hours to grind out all those welds that you put in with the wrong rod. All right, so how do I choose the right electrode for the job? That's the question. How do we pick the right one? So a few things we need to know. What metals are we working with? Is it a hardened steel? Is it a regular steel? Is it a chromoly type steel? It's, there could be all sorts of different types of things. What are we welding? Is it going to be art or is it a crane? That's really going to determine what we need here. If it's a crane, we know it's going to be taking a lot of stat or dynamic loading. It's going to be seeing force is applied from one direction than another, because as you pick up that load, it's going to stress the crane. Then as you let the load down, it's going to de-stress the crane. So you want welds that can take that bit of movement. Art, if it's hanging off a wall, you don't need to worry about it hanging or taking a lot of stress. So you can weld it with a rod that, say, doesn't take stress well. 60-10, 60-13, 70-14, things like that. They aren't that great for dynamic loading. But if it's just a stationary piece that's not moving, you can use something like that. Next question, how strong does a weld need to be? Well, 60-10 is a 60,000 pound tensile strength rod. So you think of that, there's 60 there. I've used 110-18, so it's 70-18. That's actually 110,000 pounds tensile strength. So it's, you know, it all depends on what you're doing, what you're working with, and what the job calls for. What position? That's important because certain rods can't be run in certain positions. 70-18 is very nice. You can run it in all positions. So if it has the designator 1 before the last digit, so that 1 on the 18, that means it can be run in all positions. If you're running something like a 70-24, if it's got a 2 there, it's going to only be good for flat and horizontal. Usually rods with a 2 designator in front of them are going to have a lot more iron content in the flux. Maybe I showed you guys in class. I don't know if I did, but I took a 70-24 rod. I smashed all the flux off of it. And I go and grab my magnet rod, the one that I use for cleaning up the saws with. And I pick up all the flux off the table with just a magnet because there's so much iron content in the flux. And that is to help you do a bigger weld. So something like that, I would not take into vertical or overhead. It would just be mayhem and chaos. Next, what size does the weld need to be? You know, we've worked with some smaller welding rods in here. I welded with 1/16 of an inch welding rods, little tiny things that are running at like 35 amps. I've also run, you know, 1/4 inch plus welding rods at 275 amps, right? It's a whole variety of size. So you got to match the job for the rod. That's just an efficiency thing. Let's see, where is it going? So that's another question. Where is it going? So if it's going on public display and everyone's going to see it, you obviously want to have a nice looking weld on there. You want something like a 70-18 with a good finish. But if it's getting buried underground, you don't have to have that nice of a finish on it. So you could downhand 60-10 everything. You know it's going to be strong, but it may not be the most visually appealing. So if it's going to go underground, you can definitely find ways to expedite the process a little bit. And that's kind of what I like to do, is you got to know where it's going. I worked for a company called Zircon Research Group for one little bit. And what they did is they had me build bases for monitoring devices that they would place in the bottom of local ponds. So the pond we were working at was by Chaparral. And there's a wastewater pond there. And they had me build this base. The guy says, I don't care what it looks like as long as it's stuck together. So I grabbed some old rod that wasn't really good for anything. I used that, got that out of my truck and stuck the stuff together. And then we threw it in a boat and we rowed out to the middle of the pond and dropped it down there with all the monitoring equipment. We hung a buoy off it so we could go get it later. So if it doesn't have to be pretty, don't waste your time making it pretty. But if it's got to be pretty, definitely take the time to make it that way. What metals are we working with? Well, we need to know this. First step to selecting a welding rod is knowing what base metal you're working with. Stainless will need a different rod than mild steel. Cast iron will need a different rod than aluminum. Knowing your base metal is one of the most important things when selecting electrodes. And yes, you can weld all 4 of those items with the shielded metal arc welding process. You can weld stainless, you can weld cast and aluminum, all with rods. So what are we welding? When it comes to rod selection, knowing what you're going to be welding is important. Does this piece see stress? Is it static or dynamically loaded? And what does it do? So a building like this, lots of surface area, large winds downtown, this building's going to move. And in fact, it was kind of interesting. We'd be up on top and we'd watch it move. We'd compare it with other buildings and it would move 6 inches back and forth. How strong? Like we kind of talked about this one earlier. Knowing how strong a weld needs to be will help when selecting an electrode. It'll also help when making your weld size. Strength is not a factor, then choose a rod that makes the job easiest to complete. If you choose a rod that isn't strong enough, though, you may have to redo the job, and this equals lost time and money and upset employers. And next question is, how big does it need to be? Knowing the required size and dimensions is another key factor when deciding what electrode to use. So creating large welds with a small electrode will waste time, money, and materials. So if you're working with a 3/32 welding rod and you have to do a 30 mil fillet, you're going to be there making 60 passes on that weld. And it's going to be ridiculous. It's not very efficient, but if you use something like a 5/32 or a 3/16 welding rod, you're going to make a lot less passes, waste a lot less material and time. So I kind of talked about this one. Where is it going? Is it going to be seen or will it be hidden? Knowing this will help you pick the correct rod for the job. So going underground, you can use something that allows you to work fast while still meeting requirements. So 80-10, a lot of these rods have different designators. So 60-10 is our standard rod that we're using here in the class. 80-10 is 20,000 KSI, basically stronger. And what that is used for is downhand pipe in the field. So they'll put a root in with it and they'll weld the caps with it, all in the downhand position. It's quick, it's efficient, and it meets all the strength requirements they need. So that's what a lot of pipe welders have taken to. So how do I know what rod to use? It can be confusing, but if we just kind of go back over the factors we talked about there, we can generally figure out a pretty darn good rod to use. So most are going to have an identifier label stamped on the rod, usually near the exposed contact area of the core wire. These labels are made up of numbers, usually 4 or 5 digits. So 5 digits, it'd be 1, 10, 18 kind of thing. 4 would be a 60-10 or a 70-18. But we also use 2 systems to identify these welding rods. And yeah, we use the CSA and the AWS systems. So we have an electrode identifier label. Some rods will have different color fluxes despite being the same type of rod. The flux color is determined by the manufacturer. Basically, it means nothing. It's just whatever they decided to make it. Some companies will use color coding for certain things. They'll use, say, blue here. We can see it says 308L. That's a stainless rod. Sometimes for AC rods or rods that run alternate current, like a 6011, they'll do them green. The 6010s are going to be gray. 7014 can be brown. It's just whatever they decide for that company. So welding rod ID. We're going to talk about that identifier label. So what we have here is E, always stands for electrode, lets you know what it is. 70 here is tensile and KSI, that's thousands of pounds per square inch. 8, the 1 for the 8 is the position, so 1 is an all position, 2 is a flat and horizontal. 18 is the type of coating and current, and sometimes we see the H4R here. So hydrogen is what that stands for. It's a low hydrogen rod. 718 does not like moisture. So that's what this means here. The 4, so if we look here, H4, well, basically H4 means it's got to be less than 4 milligrams per 100 grams. H8 is less than 8. So some of them are a little more tolerant, like the H8, but the H4 is a low hydrogen rod. And the R meets the requirements of the absorbed moisture test. So if it's absorbed 4 grams of moisture, it will still run fine. Basically, it's how they just guarantee the quality of the rod. So the first 4 numbers are the important ones. The trailing numbers and letters are different for certifications and applications. But we're talking about what's in those rods. here is a nice little chart here that's going to tell you. So 6010 would just be 60,000 KSI or 60 KSI, and then it's a high cellulose sodium. The cellulose is basically a wood derivative. That's what it's used in paper, things like that. That's why they smell like a campfire. 6011, same thing. It's run AC or DC, DC positive or DC negative. So very useful rod. You can run that pretty much however you want. Just grab a machine and however it's set up, you can slap the 6011 in there and run it. 12, high titanium potassium. Anyways, yeah, there's a whole bunch. It talks about, so 7014, we use a fair amount in here. It's got lots of iron powder in it. That makes a bigger weld, so it's good. What else do we use in here? The 18 iron powder, it's low hydrogen, so in 7018. We also use a 24 iron powder in titania, AC, DC negative, or DC positive. So we can run that pretty much any way we want. What I've done here is I've provided a couple of sheets that I basically see in industry, or I use for reference materials when trying to figure out welding rods. And Ready Arc Rentals is, they're good at providing a lot of information. They like giving it out because they like people to be educated. So I use a lot of their stuff when it comes to PDFs and little charts and stuff like that. So common rods and their properties. This just lists a lot of common rods here. I'll let you guys explore that more on your own time. But the certifications we have here, two commonly used classification systems for welding rods. So we got the CSA, then we have the AWS. We've talked about CSA lots, so we should be somewhat familiar with that. CSA is that governing safety body for Canada, right? The AWS is the American Welding Society. So the CSA, in Canada, welder qualifications carried out according to CSA standards, and ASME, the ASME code is typically used for pressure vessel and pressure piping applications, and CSA are used for structural and general manufacturing. So ASME stands for the American Society of Mechanical Engineers. They've set out a really good guidelines, so we've adopted that here in Canada, and that's what we use. There are three major CSA standards to which welders must be qualified. CSA W47.1 for steels, including stainless steels, CSA W47.2 for aluminum, and CSA W186 for reinforcing bars. So when I was doing structural downtown, I was certified for CSA W47.1, as well as passing my all position shielded metal arc welding tests. So I had those. I didn't have to do aluminum there. And reinforcing bars, you don't see a whole lot of that. A lot of concrete stuff. I never really dealt with that too much. Underneath these CSA standards, though, welder qualification testing is carried out every 2 years by the CWB, the Canadian Welding Bureau. And these are all hot links, so you can click on those if you want, and it'll kind of give you a breakdown of what CWB is. American Welding Society, the AWS, was founded in 1919 as a nonprofit. Global mission advances science, technology, and application of welding, alloy joining, and cutting processes, including brazing, soldering, and thermal spraying. So that's kind of cool. Headquartered in Miami, the AWS is, they've got a pretty cool building. I've never been able to tour it. I've seen pictures of it. I'm hoping to tour their building sometime in the next few years after COVID's up. There were some welding instructors that were all talking about going down and checking that out. So that'd be cool, a good educational trip. AWS serves over 73,000 members worldwide and is composed 22 districts, 250 sections, and student chapters. Society is dedicated to supporting hundreds of thousands of industry professionals, including welders, business leaders, sales service teams, manufacturers, vendors, associations, educational institutions, committee volunteers, and students. Holy, what a mouthful. So the organization is best known for its code and certification procedures. They set the standards. They've got great standards. basically, yeah, through their publications, internet forums, social media, member services, events, they basically keep professionals up to date. And yeah, they love getting out there, talking their stuff, bringing it to the public and making everyone aware of it. So what the AWS governs is a lot of stuff. AWS breaks their industries down into a lot of different sections. So you got pressure vessels, we have bolting inspection. So I don't know if ever did some of the bolting I was doing downtown with some bigger buildings. So they would govern that. They'd govern the drawing readings, pipelines, aerospace, railroad, welding, aluminum, structural steel, all of it. They got divisions for all of it. So AWS and CSA classifications. So low hydrogen covered electrodes. So R7018 or a low hydrogen electrode could be seen as Adamark 7018. So a lot of these companies will give it their own name. Say if Juveridge was making his own 7018, he could call it, you know, I don't know, Juveridge Rocks 7018. Cool. It doesn't mean it's any different than a regular 718. So the AWS class would be E718. Generally, we'd follow all of this stuff here, and you know, it has a 718 stamp on it. You might have a little special name on it or a cool picture on the box, but it would generally be manufactured to all these standards here. So basically, just a regular 718 with a cool name. I got this little video here: welding tips and tricks, small electrodes. Pretty neat video. Surprised we can get, oh yeah, we're gonna get hit with an ad. So we're not gonna go over the whole thing. I'm gonna go through a bit of it. You guys can go through the rest on your own time. All right, guys. So that was just a little bit of that video there. You guys can feel free to dive further into that on your own time. Probably be a pretty good review too. I'm going to have a quiz coming up for you in a day or so. and that will be helpful. I will post up some other material for that quiz, some review stuff, make sure everyone's on topic and on point with the right material. And then, yeah, that'll be it. So that's it for today, guys. Don't have a whole lot for you. Just a little bit of electrode talk. I've got that slideshow posted up in our D2L. It is in the class materials unit of arc welding 1. So new unit, we're not working out a print reading anymore. We're working out arc welding 1, and you'll see it in there. You'll see online classes. That'll be, if you've missed any classes, you can go back, check there. If we haven't really done anything that day, we didn't do anything too important, I won't include that lesson. I'm going to include the important lessons for everyone. So a copy of today's lesson is going to be in there as well. I'm going to do that in just a bit. But did anyone have any questions about anything going on? Any questions on welding rod stuff? Anything you're curious about? No? Okay, cool. Welding rods, they get big. There are 3/4 inch welding rods out there that run at 1,000+ amps. Those are generally machine operated, but I'm going to see if I can somehow get my hands on one and get one for the classroom. They're not cheap, but I think I may have a connect. I got to dig around, see if they still have any. And if I get one, I'd be this cool little display piece for the class. All right, so thank you much, guys. I appreciate it. Yeah, check out the rest of that video on your own time. And that's it for today. So hope you guys had a great weekend. I had an okay one. Wasn't the best, but you know, could have been a heck of a lot worse too. So yeah, with that, everyone have a good day, and I will chat with you tomorrow. We're just going to keep using this link, and yeah, we'll get to it and get all the stuff knocked out and come back here and weld our butts off. All right, see you guys. Have a good day. Bye.